So here I am with the new types of matrices. Last time we had discussed up to the, I think the diagonal matrix. From diagonal matrix we have to start. So when we talk about a matrix, a diagonal matrix, okay, let me read out to you. A square matrix in which every non-diagonal element is 0, that is called as a diagonal matrix. I'll give you an example of the diagonal matrix. Let's say if this is a matrix, okay, if I give you A is a matrix having these elements. Okay, now in this case it is clearly visible to us that the diagonal is given, isn't it? Can everybody see the diagonal? Yes, so the diagonal here is 5, 5, 4. The diagonal elements are 5, 5, 4. So you can observe that in diagonal matrix, the diagonal elements are numbers other than 0. Understood everyone? Okay. Now let us move to the next matrix called as a scalar matrix. Okay. A diagonal matrix in which all the diagonal elements are same is called as a scalar matrix. Now everyone, can anybody from you tell me what exactly is a scalar matrix? Shall I give you an example everyone? Okay, alright. Let us suppose we have B as our matrix. You know, scalar matrix means all the diagonal elements have to be equal to the same number, right? So if I say 2, 0, 8, can we say this is a scalar matrix everyone? Yes, it's a scalar matrix. Why? Because if you can see, the diagonal elements are all one and the same. That is, the diagonal elements are 2 in this case. All the elements are 2, 2, 2. Alright? Now, there is a next matrix called as an identity or a unit matrix. Does anybody know what is the meaning of unit matrix? Unit matrix is nothing but a matrix in which the elements are in this form. Okay? So, let's say 1, 0, 0, 0, 1, 0, 0, 0, 1. So, can you see a unit matrix? You know, all of us know that when we say unit, it is 1, right? So, in a case of a unit matrix, you can see that the diagonal elements are going to be 1. All the diagonal elements are 1. So, now, can anybody tell me, is unit matrix a scalar matrix? Yes, unit matrix can also be a scalar matrix. Why? Because the diagonal elements are present while all other elements are 0. Yes? So, I will say that the identity matrix is a scalar matrix. Isn't it? Alright. Now, I am going to read out 2 important points for you. Okay? Every identity matrix is a scalar matrix, but every scalar matrix need not be an identity matrix. However, a scalar matrix is a scalar multiple of identity matrix. So, when I say scalar multiple, let me give you an example for this one. Alright. So, when we talk about a scalar matrix, let's say, okay, let me give you an example. If matrix A, they have said that every scalar matrix is a diagonal matrix, but every diagonal matrix need not be a scalar matrix. Okay, understood? So when they talk about scalar multiple, so I am going to explain you the meaning of scalar multiple. Suppose we have a unit or identity matrix which is given over here. Now when I say scalar multiple, if I say that you have to multiply this particular matrix by 3, okay, so 3 is going to be our scalar in this case. So if I say 3, you have to multiply this matrix by 3. What is the meaning of that? I have written 3 outside, which means each and every element inside the matrix will be multiplied by 3. When we say a scalar multiple, that means you have to multiply it by 3. Understood? So if we say you have to multiply, this is going to be 3, 0, 0, 0, 3, 0, 0, 0, 3. So did you observe what I have done? I have multiplied a scalar 3 to each and every element of the unit matrix. So now I have got a scalar matrix, okay, which is not a unit matrix or which is not an identity matrix. Understood? So you have to know the actual difference between an identity matrix and a scalar matrix. It is not that difficult at all. Alright? Now, yesterday if you remember, I had taught you that whenever the number of rows are less than the number of columns, okay? Let me give you an example for this one as well. Suppose there is a matrix called as C, okay? And suppose the elements of these matrix are like these. If you observe, you remember yesterday I was teaching you that the number of rows are given by I and number of columns by J. So in this case, how many number of rows? 3 number of rows. And how many number of columns? Again, it is 3 number of columns itself. So we say this is a 3 by 3 matrix. But now if you can observe, okay, observe this matrix very, very carefully. So when you observe, what do you understand? You can see that this particular triangle is formed. Okay, alright. So when we say an upper triangular matrix, a square matrix in which every element below the diagonal is 0, that is called as an upper triangular matrix. So if you can see over here, can you see a small triangle? Yes, all these elements are 0 and you can see the triangle over here. So this is called as an upper triangular matrix. Understood everyone? Upper triangular matrix. So this matrix is of the order 3 by 3, you know, because the number of rows and columns are equal. But there is a condition. Whenever I is greater than j, then we say it's an upper triangular matrix. And whenever I is less than j, we call it is a lower triangular matrix. Okay. So I'm now going to show you lower triangular matrix. Yes, can you see it everyone? Yes, that's right. So if you can see over here, this is a triangle that is formed and which is nothing but a lower triangular. So this matrix is called as a lower triangular matrix. Have you understood? Okay, so let me write it down for you. This is a lower triangular matrix. Right? Yes. Okay. Now, these are the few types of the types of matrices which we are studying. Now, today I am going to teach you how to form a matrix and how to find out determinant of a matrix. See, always remember, when we say determinant of a matrix, what is the meaning of determinant? That means the value of that particular matrix. Okay, so let me give you an example for this. This is a very, very important concept called as determinant of a matrix. And after this concept, I will be teaching you regarding how to form a matrix when a given condition is given to you. Okay, yes, it's very, very easy. So please Everyone concentrate. Determinant of a matrix. Determinant is nothing but absolute value. Does anybody know what is the meaning of absolute value? When we take absolute value, let's say if I take this value, I hope everybody knows this is an absolute value bracket. Yes? So always remember, when it's an absolute value, you always have to consider the number and not the sign. Okay? So even though here inside the absolute bracket sign you can see a negative 41, but while taking its value, I am going to take it directly just the number and do not consider its sign. So always you have to take it as a positive value. Understood? So when you take anything out of an absolute value bracket that is given over here, then we are just going to consider its positive value. Okay, this was just a basic which I wanted to tell you everyone. So now let us move on to determinant of a matrix. Suppose I give you a matrix. Now remember, since I have to find out, let us say this is a determinant D. This is a matrix D and we have to find out determinant of D. Okay. So how are you going to find out the determinant? So now pay close attention. Okay. You have to take the first element. What is the first element in our case? It is 3. So in order to find out the determinant, what I am going to do is 3. Okay. Now take this particular 3 and do not consider this row and this column and this row. So if you just don't consider this column and this row, then you can see that there are these numbers 0, -5, 3, 1, right? So what I'm going to do is 0, I'm going to cross multiply these two and put a minus sign in between. So if you can see, we have taken the first element. I'm not considering that row and that column, ignoring that and taking the other elements, okay, and cross multiplying the elements, and you have to put a minus sign in between. I'll show you how. So when we take this 3, okay, I'm not going to consider this row, this column, and 0 into 1 minus of -5 into 3. Understood? Alright, so what is our answer? 0 into 1 is 0. Minus of minus, remember integers, rules of integers, when you multiply two negative values, you get a positive value, and 5 times 3 is going to be 15. Yes everyone? So now what I am going to do, it is going to be 3 okay, this is only for this particular row and column, so this particular element. So if I take the next element, okay, next element is going to be my -2. So how I'm going to do it? -2, just skip that particular column and that particular row and take the next elements. So in this case it is going to be 0 into 1 minus of -7 into -5. Okay. So while taking the middle element, see, first what we are going to do, we are going to learn how to find out the values. Okay. So if you can see over here, it is going to be -2, 0, minus into minus becomes plus. So it is going to be plus 35. And it is going to get this particular minus sign. So I am going to write it down as -2 into -35, that is plus 70. Okay, and now let us consider this element. Can you see this? So if I take 4, yes, if I take 4, yes, so you have to just skip this particular column and this particular row and cross multiply these. So 0 into 3 minus of 0 into -7. Be very, very careful with the signs. If you go wrong in any particular sign, then you will not get the correct answer. So now, while finding out the determinant value, what I am going to do is, consider this 45. See, 45, this is the middle value, minus 70 plus 0. That is going to give me the determinant. Yes? I hope everybody has understood. See, this particular second element in this particular matrix, you have to give its value a negative sign, which I have done over here. That is why, even though here we got plus 70, I am going to substitute it as minus 70. Okay? So, what is the value of this now? This is 0, 1 is positive, another number is negative. So, what will you do? Subtraction and sign of the greater number. Which is the greater number in this case? It is minus 70. So, I am going to take the minus sign and do the subtraction. Is it right, everyone? Yes? Understood how to find out the determinant value? Alright. So, let me give you another example, an easy example maybe, so that you will understand this in a very, very clear way. See, okay everyone? Yes. Now I am going to give you a very, very easy value. Let's say 1, 2, 4, 6, this is our matrix that is given to us, and you have to find out determinant of this particular matrix. Yes, so what will you do? Determinant A, 1, so skip that particular column and row, so 1 into 6. Yes? Is it right? Have you understood? 1 into 6, then I am going to take this, skip it. The determinant of this particular 2 by 2 matrix value is going to be plus 2. Is it easy? I think it is more easy for a 2 by 2 matrix, isn't it? Because there is no multiplication. You just have to skip that particular column and row and just take the value. Yes? Understood? Okay, alright. Now, what I am going to teach you today, one more thing, one more very, 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 very interesting topic is how to form a matrix when a given condition is given to you. Let's say, for example, the condition is given to you. You have to form a matrix A of ij such that it is going to be I minus j raised to 2 upon 5 minus I. Yes? Now see, can anybody tell me what is I and j in this case? I are the number of, yes, I is nothing but the number of rows and j is nothing but the number of columns, isn't it? Okay, so now I have to form a matrix A of ij in such a way that this condition is satisfied. Okay, and they have not mentioned whether it's a 3 by 3 matrix or a 2 by 2 matrix. Okay, they have just told you construct a matrix A such that this is the condition, and I and j value have to be, I value they have told us to take it as 3 because there are 3 number of rows, and j is 2 because there are 2 number of columns. So the same values I am going to substitute to find out the first element in our matrix. Okay, so A, since it's a 3 by 2 matrix, yes, so when we say 3 by 2, what is the meaning of that? 3 number of rows and 2 number of columns. Yes everyone? Okay, so I am going to find out element A32, okay, which is going to be, I am just going to substitute the value of I as 3 and j as 2. So I 3 minus 2 square upon 5 minus 3. Yes? Okay, so what is the answer? 1 square is 1 upon 2. So I am going to construct this particular matrix in which A32 element is there. You know, right? A11, A12, A13, A22, sorry, A21, A22, A23, A31, A32, A33. These are going to be our elements. Okay, now it is A32. So what do we need to do? We have to substitute this value over here. So we have got our first element. Okay, this is a 3 by 3 matrix that we are going to form, a 3 by 3 matrix. So what I am going to do now, I am going to take the value of I as 1, j as 1 and substitute it. So in this way I can find out A11 element, this element I am going to find out now. Understood? Okay. So when I say this element, 1 minus 1 square upon, it is nothing but 5 minus I. So 5, first element is going to be 0. See, again, a very important concept in this. See, whenever in the denominator you get a number and in the numerator there is 0, the value of it is nothing but 0. Yes, because in maths when denominator is 0, then that number is undefined. Always remember, in the denominator part if you are getting 0, that means your answer is wrong. Alright? So everybody, you have to keep this in mind. Okay, so this value is nothing but 0. Understood? Now let us substitute the next value to find out A12. So when we say A12, I am going to substitute it as A of 12 is going to be 1 minus 2 square upon 5 minus 1. So what answer are we going to get in this case? Yes, that's correct. So the answer is going to be minus 1 square upon 4, that is nothing but 1 upon 4. So my A12 element is 1 upon 4. Understood? Now the next, A13. Just substitute the value in the given condition to find out the values faster. So A13 I hope everybody is understanding what I am trying to do over here. So this element is going to be 1. Yes? Next, A21. A21, value of I is 2, j is 1. So 2 minus 1 square upon 5 minus 2. That is going to give us 1 upon 3. So the second element is going to be 1 upon 3, everyone. This one, A21. Okay. Now find out A22. Yes. So what is A22? Let's find out. 2 minus 2, 0 upon 5 minus 2. Again you get 0 over here in the numerator part, and in the denominator part you are getting 3, isn't it? So it is going to be, our answer is going to be 0 eventually. So this element A22 is 0. Yes, isn't it interesting? Okay, let us find out the next one. We are going to find out now A23. So the value of j is 3. A23. Yes, it's 1 upon 3. So A23 again is 1 upon 3. Now we have just two elements to find out. Which are those? A31, A33. Come on. So A31. When we say A31, substitute it. A31 is going to be 3 minus 1 square upon 5 minus 3. So 2 square upon 2, 4 upon 2, that is nothing but 2. So this element A31, guys, it is 2. Okay. And the last element A33. So substitute the value of I as 3, j as 3, and you will get A33, which is nothing but, again in this case, are we going to get a 0, guys? Yes, we are going to get 0. So finally we have formed our matrix A with these following elements. Okay, from this condition that is given to us. Yes, isn't it interesting? Yes, that's right. So our final matrix has the elements 0, 1 upon 4, 1, 1 upon 3, 0, 1 upon 3, 2, 1 upon 2, 0. Understood? Okay. Hello everyone. So today I am going to teach you a new concept called as singular matrix. Okay. Let me read out to you. Last time, if you remember, I had taught you how to find out determinant of any matrix. Okay. Now today we are going to learn a concept called as singular matrix. Okay. So a square matrix A is said to be a singular matrix if determinant value. Today we are going to learn the concept of singular matrix. Its determinant value, if that value is equal to 0, we say it is a singular matrix. Otherwise, it is called as a non-singular matrix. Understood? A square matrix whose determinant value is going to be 0, that is called as a singular matrix. And if its value is greater than 0 or some other value than 0, we say that it is a non-singular matrix. Alright. So suppose we have, let's say A is given to us as 2, minus 1, 3, minus 7, 4, 5, minus 2, 1, 6. This is a 3 by 3 matrix. Yes? As I had already told you, the number of rows and number of columns are 3, 3 each. So this is a 3 by 3 matrix, isn't it? Alright. So now what we need to do is, we have to find out determinant value of this matrix. So let us find that out. Determinant value, 2 into bracket, as I told you, you have to skip that particular row and column. Take a minus sign for the middle element, again minus 1 into bracket. Skip, so minus 7 into 6, minus of 5 into minus 2. And the third element 3, skip this column and row, so it is going to be minus 7 into 1, minus of 4 into minus 2. See, now you have to be very, very careful with all the signs, okay? Do not be in a hurry to find out the value. Do it correctly in your mind. So if you can see over here, this is going to be 19, okay. So this minus of minus 1 will be plus 1 into bracket minus 7 into 6. 6 sevens are 42 minus 10 plus 3. Be very, very careful while solving. Do not make any mistakes here. Be very cautious. Okay, then you will get the correct answer. Alright, so 19 times 2 is how much? 38 plus 1 into bracket. See, minus of minus again is going to give us plus. So here it is going to be minus 42 plus 10 plus 3 into bracket minus 7 plus 8, isn't it? Because minus of minus 8 is nothing but, yes, it's a positive 8. Okay, so 38. This is going to be how much? One is negative and the other is positive. Subtraction, sign of the greater number. Isn't it? And 3 times 1 is nothing but 3. So 38 minus 32. How much is 38 minus 32? 6. 6 plus 3 is 9. But we needed this value to be equal to 0 in order to say that it's a singular matrix. Is this a singular matrix? No. Why? Because here the value of the determinant is equal to 9, which is not equal to 0. So this is a non-singular matrix. Understood this concept? This is a non-singular matrix because its determinant value is not equal to 0. So it's a non-singular one. We are getting the value 9. Alright. So please be, everyone, please be careful while solving this, because otherwise you will lose marks if you make mistakes. So please be clear in this concept. This is the basics of integers. Alright. Yes. Okay. Now suppose I give you one more example. You have to show that this another matrix which I am going to give you over here. You have to show that this matrix is a singular matrix. Okay, the question is, show that this matrix this is a singular matrix. So again, tell me everyone, when we say singular matrix, what is the meaning of it? Its determinant value should be equal to 0. If we get the determinant value equal to 0, then we say that it's a singular matrix. Okay, let us start finding out the determinant. Determinant of A, x plus y, you have to skip this column, this row, so it is going to be y minus x minus y plus z, skip that particular column and row, so it is going to be y minus z plus z plus x, skip this column and this row to get x minus z. Okay, now we are going to solve this. We are going to do multiplication part. Alright, so this first is going to be x plus y into y minus x minus y plus z. See, this is y plus z, y minus z. You remember the identity? A square minus b square is a plus b into a minus b. Do you remember? So I can directly write it over here as y square minus z square, isn't it? And again, if you see over here, this is what? A plus b into a minus b again. So I'm going to use that identity over here to get my answer equal to x square minus z square. Yes? Okay. Now what we are going to do? We are going to multiply these two. How to multiply? Take the first element, multiply the entire bracket, then the second, multiply the bracket, minus y square. You have to change the sign over here. Do not forget to change sign over here. Right? Because it is a negative number. When you multiply by a negative number, the signs inside the bracket they are going to change, isn't it? Yes. So this is going to be xy minus x square plus y square minus xy minus y square plus z square plus x square minus z square. So now, according to our law, which law? Law of algebra, you have to take the similar, what we say, these are the similar variables together, form a group and do the addition or subtraction as required. Yes, we do that, isn't it? Alright, so what I am going to do? Plus xy minus xy, 0, minus x square plus x square, 0 again, plus y square minus y square, 0, plus z square minus z square, 0. Yes? So in this case, we are getting the value of the determinant A is equal to 0. Is this a singular matrix? Yes. Why? Because the determinant value is equal to 0. Yes? Isn't it an amazing concept? You liked it, everyone? Alright. Let me take one more example of this kind. I have taught you about a scalar matrix. Okay, so whenever you are going to multiply by a scalar value, okay, I'll take your scalar multiplication concept now. Everybody is clear? What is a singular matrix? Yes. So I'm going to take another concept called as, okay, this is actually, it's a very, very easy concept. Suppose, let me take an example for this one. There is a scalar, okay, I'm not going to teach you scalar multiplication right now. This is a concept, scalar multiplication. So what is a scalar? Suppose I give you an example. Yes, so now I have to multiply. Let's say this is a matrix A, this is your scalar quantity and these are your elements. Okay, so now when we have to multiply, what we need to do? We have to multiply that scalar to each and every element present inside the matrix. Okay, so what are we going to do in that case? Yes, I am going to multiply 4 times 3 is 12, 4 times 5, 20, 4 times minus 6, minus 24. Do not forget to give the sign. Alright, then 4 into minus 4 is minus 16, here is 24, here is 4, 32, 8, minus 36. Understood? So what I have done is, scalar multiplication means what? You have to multiply the scalar quantity to each and every element inside the matrix. Yes? Understood? I hope everybody has understood. Yes? Okay, so this concept is called as scalar multiplication. Understood? Alright. Now, I am going to teach you how to find out transpose of a matrix. See, last time I had taught you regarding determinant of a matrix. Then right now I taught you about the scalar multiplication. And one more concept, that is of singular matrix, is what is done. So now I am going to tell you how to find out transpose of a matrix. Okay, so let me read out to you. A is a matrix of the order m into n. The matrix obtained by interchanging rows and columns of matrix A is called as transpose of matrix A, which is given to us by, see, so this is transpose . If we have to find out transpose of a matrix A, it is denoted by, is it right? Understood? A transpose. So now suppose the matrix A is given to us as what is the concept? Yes, can anybody tell me? I just read out to you. When we say transpose, the meaning of that is you have to interchange the rows and columns in this case. Yes? How will you interchange the rows and columns? Very easy. What I am going to do, in order to find out A transpose, I am going to take this particular column and write it as a row. Then take the next column and take it as the next row, and third row would be 6, 8, 1. Understood? So the matrix A is given to us. Yes, the transpose of a matrix we can find out by interchanging the number of rows and columns. Yes, so understood this concept. Let me see. I'll give you another one and find out the transpose of this. As I told you, the number of the first column, you have to write it in a form of a row, isn't it? So I'm going to write 2, 2, 8 over here, 1, 9, 2 over here, and 4, 4, 6. Understood the concept of transpose? Easy, isn't it? Okay. Okay. Now, one more important concept. Yes, in today's class, I am going to teach you all these important concepts so that it becomes easier for you to do the operations. The next type of matrix is called as skew symmetric matrix. Okay, So now many students get confused in the concept of skew symmetric matrix. So what is skew symmetric matrix? Let me read out to you. A square matrix A of ij of order n into n, in which A of ij will be equal to minus A of ji for all I and j, that is called as a skew symmetric matrix. In a skew symmetric matrix, each diagonal element is 0. So what is the first condition? If I tell you, let's say there is a matrix B 0, 4, minus 7, minus 4, 0, 5, 7, minus 5, 0. Okay, this is a matrix B. Okay, now if you observe, the first condition for a skew symmetric matrix is that the diagonal elements, can you see the diagonal? All elements are 0. So the diagonal elements in this case are 0. Yes? So now that's the first condition of a skew symmetric matrix. Now what are we going to do is, if you observe all the other elements, let's say if you observe this triangle and this triangle, can you see the signs are interchanged? The numbers are same, but the signs are interchanged. So whenever somebody tells you that you have to, find out which type of matrix is it, so you have to observe these two things. First condition, that is the diagonal elements have to be 0, and the second condition, the upper triangular and lower triangular elements are same, the values are same, but their signs are different. Yes? Understood? So this is an example of a skew symmetric matrix. This is a very important thing, everyone. Please make sure that you have understood this skew symmetric matrix. Why? Because many students, they don't understand only what is a skew symmetric matrix. The skew symmetric matrix has to fulfill two conditions. First condition, that the diagonal elements have to be 0, and second condition, the upper and the lower triangular elements, they just change their signs. The numbers have to be same, but the signs have to be different. Isn't it? So in this case, if we see, this is minus 4 in lower triangular, but in upper triangular it is plus 4. Sign has changed. Here it is 7 in lower triangular, in upper triangular it is minus 7. Again, minus 5 in lower triangular, plus 5 in the upper triangular. Okay? So this is the concept of skew symmetric matrix. Alright? Yes.